Good evening, everyone. This is Satya, technical lead. So already for CSC branch and so one of the EC section also I have Good evening, taken everyone. This is
training.
Satya, technical lead. So taken try given training in your college and for remaining branches. So I am new for you. So already for CSC branch, so I have introduced dynamic programming. Okay. So, but don't worry for remaining branches. So I am going to introduce dynamic programming. So and I'll explain the programs based on the DP. So coming to the hack with Infy, so I have to face some three coding questions. So one is from easy level, second one is from medium level, third one is from hard level. So these programs you'll get from data structures. So obviously, so that is array strings, stacks, queues, trees, and graphs. Next of all, dynamic programming, so greedy and backtracking. So actually, for you, data structures part is not completed. So let us try with the dynamic programming, so greedy and backtracking because for each and every section, dynamic programming and array spot and next of all recursion completed, right? So with the help of that knowledge, so you can study these programs, greedy, backtracking, and next of all dynamic approach programs. Okay. So today, I'll start with greedy approach program. So before going to start this, I have to intimate one thing. So if session terminates abruptly, or else if any problem occurs, so try to rejoin. So myself from my side also, I'll rejoin again. So from your side also try to rejoin. Okay. Now and if you want to know the any information regarding the trainings and placements. Okay. So if you want to watch the any upcoming videos from our institute, so subscribe it. Okay. So that you'll get the notification and you can watch it. Okay. That's fine. So first of all, I'll introduce greedy approach here. Later on, let us see the programs based on it. Okay, definitely you'll get programs based on greedy and dynamic programming. So there is no doubt in it. Okay, that's why today we are targeting this one. Actually, both dynamic programming and greedy approach programs used for optimization problems. Okay. So, but the way of designing solutions prefers here. Both we use it for optimizations only, that is for maximization and minimization programs. Okay, actually in dynamic programming from different paths. Actually, we are going to get the maximize and next of all the minimize result. But here in greedy at each and every point of time, so we are going to try to get the optimal solution. Okay, so that the entire solution becomes optimal. The same thing you can observe in the second point here. Okay, observe the algorithm makes the optimal choice at each steps as it attempts to find the overall optimal way to solve the entire problem. Each and every step, so we try to get the optimal result so that the entire problem solution becomes optimal. Okay, that is what you are going to observe the in greedy approach. Okay, when compared to the backtracking and next of all the dynamic programming, so it's easy. Okay, uh, yeah, greedy approach programs easily you can design it. You are going to observe that. Okay. So just I'll discuss the most important coding section and next of all interview programs. Okay, in this program, so one of the program given in the previous year Infosys also HackWithInfy and next of all TCS Digital also. Okay, so might be if you may get the same program or else you may get the same model program, so it will be useful for you, right? Okay. So actually, I saw in the website sir, that at least some 1.5 to 2 coding questions execute, so chance will be there to move to the second round. Okay, that's why we should not give up. Okay, always we should try at the end up to the ending. we should try to give our best. Okay, so that is what we can do it from our end. That's it. So greedy approach I'll explain with so one example. Listen that actually that program is present in different platforms also. Actually, one foreigner came to our country. Okay, so now actually we want to exchange. We want to exchange. So amount exchange amount. So in our currency. Okay. So for suppose let us take. So he is having some amount called uh, so 7 rupees. Okay. Let us take some small value. Afterwards, let us work with the big values also. Okay. So what number rupee coins with us? Okay, let us take 1 rupee, so 2 rupee and 5 rupee. Apart from this, we have some 10 rupees, all this also. But now these are enough. Okay, so for returning change to this amount 7 rupees. Okay, so how many here? In how many ways we can return? So change to this amount 7 means you can give some 1 rupee coin 7, right? This is one way. So this is one way, or else we can give three 2 rupees coins and one rupee coin, right? So next, so I'm taking another number of ways were there. Okay, so just I'm showing you some few ways here. That's it. So next, let us take so 2 rupees and 5 rupees. Okay, so if you compare with all these, with this, we can provide so the minimum number of coins, right? With the minimum number of coins, we can provide so change to the amount 7 rupees here. Okay. So here the greedy way of thinking is we should return so the minimum number of coins. So likewise from program to program, so it differs. Here minimum it is from the minimization model. Okay, some programs are based on the maximization model. The greedy way of thinking here is we should return the change with the so minimum number of coins. Okay, so this is what you are going to observe in the first program. Okay, first of all, so I'll read that problem statement also from Coding Ninja's platform. Okay, so afterwards I'll explain so how to design so the solution of that. Okay, how we can return so the minimum number of coins here. 1 minute. Uh, so fine. Let us see the problem statement first of all. Okay, after seeing that, so I'll explain how we can so the design it. Okay, let us see. Let me search. So here in this platform, Code 360 by Coding Ninjas. Okay, in this one, uh, for each and every program, you can check. So how many times it is repeatedly asking in different companies. Okay, so here you can check. So we have two programs based on so coin change. One is ways to make coin change. This is from dynamic programming. Just now I showed you the number of ways, okay, to return the change, right, for some 7 rupees. So that program we are going to discuss in dynamic programming. So now we are going to observe this, that is find minimum number of coins. This one also asked us some 15 companies, okay, interviews. So let us see this one. First of all, let us see the problem statement. Have fine. So observe the problem statement, everyone. So given an infinite supply of Indian currency, so that is 1 rupee, 2 rupees, 5, 10, 20, 50, 100, 500 and 1000. So earlier we have some 1000 rupees, now we have 2000 only, 1000 rupees band. So this is already this is given, this is prepared at the time, okay, before to the currency band. So right, valued coins are given, and the next of all, along with this, an amount n is also given. Okay, so to that amount, so we should find. So how many minimum number of coins we need to return? Okay, so that one you can read in the second point here. Find the minimum coins need to make the sum equivalent to the n. Okay. So means here we need to return the minimum number of coins so that the coins amount sum should match with the n value. We have to return the list containing values of coins required in the decreasing order. Okay, so decreasing order means, so here with this line you can clearly understood that so on traversing in the reversing direction only, so we are going to get the uh, coins in the decreasing order, right? So already I said in the sessions also, classroom sessions, that reverse model is very important. Most of the programs logics we can design with reverse order, and next of all, most of the programs we can make faster. We can make run faster with the help of reverse logic. Okay, same thing you are going to observe here. This program logic we are going to finish by traversing in reverse direction. Okay, we have to return the list containing, we need to return the list here. So initially we need to take some empty list. Okay, already in the classrooms trainers showed you how to take some empty list. So all this, so afterwards to that list we are going to add all the values. Okay, might be some method called append also introduce it. So for you how to add values to the list. Okay, so fine. So here some example is given. So check everyone, that is called amount 70. Okay. So here uh, two coins only required. That is one is 50 rupees and the other one is the 20 rupees coin. Okay. It is always to find one thing note is given. Always possible to find the minimum number of coins. Okay. Always answer is exist here. It's not required to return any default values. Okay. Sample input 13 is given, 10 rupees, 2 rupees, and 1 have to return. Okay. So fine. These are the constraints, and next of all, time limit. Everything is given for us. Okay. Now I'll take one example to explain for you. Okay. All of you listen. Okay. Mm, mm. Let us take so coins 1, 2, 5, 10, 20, and so 50, so on. Okay. Let us take so n value as some 40. Okay, so we are going to traverse in the reverse direction here. Okay, that is we'll start from so this index. Okay, let us consider up to this position. So, is it possible to so return this coin 50? No, because so what we need to do here is we should check so the particular index value so with the amount. Okay, whether it's the smaller value or not. If it is smaller value, then only it is possible to return, right? So if you take 50 value is greater than of so n variable value, that is a given amount. Okay, it's not possible to return this coin. Okay, fine. So we should traverse to the before index here. Okay. So now let us check whether it's possible to return 20 rupees or not. Yes, because 20 is less than so or else even if it is so equivalent to the n value also. Okay, it's possible. Yes, it's possible now. It's possible to return now. Okay. Now here you need to remember one thing. Same thing we are going to follow in the dynamic programming also. You need to remember one point in the coin change program here. So now we are returning some 20 rupees, right? I'm taking this 20 value into the list. Okay. Now we should not move to the before index here. So that is index pointing to the value 10, because on staying at the same index, okay, so might be possibility is there to return this value again. Okay, might be it is possibility is there to return the same coin again. So that's why the whatever the condition you are observing here, we are going to take it in the so while loop. Okay. Once after collecting some that coin, we need to reduce the amount here. Okay. On reducing 20, so it becomes 20. Finally, remaining value is 20. So we are staying at the same index. We are not updating again. So 20 is less than or is equal to of n value is 20. Yes. Once again, So we are going to return the same. And after that, so this n value becomes 0. Finally, whenever n value becomes 0, so we are going to stop it. Okay. So it's not for required to further run. Okay. Though if loop runs to the previous indexes, okay, the condition, whatever the condition, so we taken here, so becomes false. Okay. So that is a thing. That's why I taken this one. This is the best example. With this, you can clearly understood, okay, whether on picking some particular coin, whether we need to move to the previous index or not, okay, or else we need to stay back at the same index, okay, current index. I hope so it's clear. So fine. First, suppose if we take n variable value as 30, okay, in that scenario after so picking 10 it's not possible to return so 20 again, okay. In that scenario we need to move to the previous index and we should collect the coin called so 10, okay. So that is a program. So this program, so now I am going to design here. I hope you understood the greedy way of thinking. So what is the greedy way of thinking here means if we traverse from the beginning, okay, so we need to return more number of coins, right? Okay, let us take so 40 only. So how many 1 rupee coins it is going to return? 41 rupee coins, okay. On traversing from the ending only, so now we are so just returning some 2 coins, right? Okay. Likewise, from program to program, so the greedy way of thinking also differs. Okay, it's not same. So for each and every program, it's having different variants. You are going to observe that. Okay, I hope so. It's clear for everyone. This is just introduction program. That's why I do not want to extend more time on this. Okay, so I'll conclude. So here and I'll type and execute the program. Okay, so all of you check, observe. If you have any doubts after completion of the so program, I'll check the chat box. Okay, if you have any doubts, I'll give you some 1 or 2 minutes time. You can clear your doubts. Okay, so fine. So this is the coding screen already given. So already some function called minimum coins given and the n variable value also passed means amount value passed here. We need to return the list of integers from the so function. Okay. So remove the comments and pass here and start typing to the code. So first thing, so we need to traverse this so list, right? List of coins. Okay. So first of all, I am taking so that list of coins here. Observe coins array 1, 2, 5, 10, 20, 50, 100, 500, and so 1000. Okay. And next, and next, what is given here? We need to return so the array of we need to return the array of list, right? Okay. So I'm taking one extra array here. Okay. So that is called a result array. Let us take result array. To this result array, I am going to collect the coins here. Okay. And what I said while explanation, so here the greedy way of thinking is by traversing in the reverse direction, right? Okay. So let us take so the reverse loop here. Might be in the classes in the beginning of explanation of for loop. So every trainer explained so the reverse for loop. Okay. If not completed, so now check. If you have any doubts, I'll explain. Don't worry. Okay. We should start from so the index minus one here. Okay. Starts with 0 index and ends with size minus one, right? Okay. And we need to generate up to 0 index here. Okay. For that sake, in the stop, we should take minus one. So here it ignores the stop value, right? Okay, that's why we need to generate up to the minus one. Okay, we should take minus one so that it generates up to 0. And don't forget to take step value negative here. Okay, so check at once. Length of coins minus one, that is nothing but size minus one. Okay, it start from so index minus one. We should generate up to the 0th position. That's why I'm taking stop value as minus one. And so the step value we need to change so that it can understood that it's a reverse for loop. Okay, If you do not change it, so it considers this one as a forward direction loop. Okay, fine. And what I said, so for suppose we have some amount called 500, okay? Is it possible to return, so this 1000, no, right? Okay. So we need to check whether it's possible to return some particular coin or not, okay? So that condition we need to check here. And what I said, that condition we should check with the loop because so might be that we need to return the same coin for more than once. Okay. For that sake, we need to take the loop, not if here. Okay. So I hope you understood. Observe this, everyone. Coins of a particular so position so coin we should check whether if it is less than or equivalent to the given amount or not. Okay. If it is less than or yes, then it's possible, right? Okay. So we can add that particular coin into the result and we need to don't forget to update the n variable value on collecting some particular coin into the result list. Okay, we need to reduce that value from the total amount, right? Okay, these two steps so already I explained. Okay, so in the example, once again you can observe here now. Okay, what I am doing, so to the result array I am appending, okay, coins of I, and next to this we need to update the so given amount here n is equals to n minus coins of I. Okay, so to that particular position value, so we are updating from the given amount, we are subtracting so that particular value here. And so likewise, whenever if it is not possible, okay, its loop iteration is going to be reduces. Okay, again that particular coin is going to check whether it's possible to return with some particular amount or not. Likewise, it collects the all coins here. Okay. Finally, after completion of so both the loops, we need to return the resultant array, whatever so minimum number of coins is added here. Okay. So it is a simple program, easy program. Okay. Likewise, by level, we'll move on to the programs here. Okay. So let us run and check whether it works or not. Okay. So here we got tab error. Okay. So fine. Observe everyone. So we should update like this. One minute. So all base case passed. Next, let us submit the code and check. Large test case checking here. Okay. Optimal code test happened. So fine. So it's executed, all test cases are passed here. Okay, second check, and so I'll give you some 2 minutes time. So if you have any doubts regarding this, you can ask. I'll keep this code in the chat box. Okay, so let us check. Think so indentation not properly added, so don't worry. Check if anyone so having doubts, you can ask regarding this. I hope so screen and everything is visible, right? Okay. So if you are facing any problem, so chat. So I'll give you a reply. So fine. I hope so. It's clear for everyone. So I'll move on to the next program here. So that is important one. Okay. So again, you are going to observe the proof also here. Check. So that is minimum n number of meetings. Let us take so this maximum meetings. Okay. So here it's nearly this one Austin, some 23 companies. So interviews. Okay. So before going to start explanation of this one, I have to explain one thing. Okay. So based on that knowledge, so we can design easily here. So because here from here onwards, so in some programs we need to collectively work with some two arrays. Okay. In order to work so collectively with two arrays, okay, what operations we need to do. So in the beginning, all this I'll explain. Okay. So have a look. So 1 minute, I'll open Jupyter Notebook. So 1 minute, just I'm opening so Jupyter Notebook here. So let us take some two arrays here, so called 3, 1, 4. Okay, next of all, so the array 2 is equals to some 2, 5, 6. Okay. So now I want to combine so these two arrays here. Okay. So based on the so the indexes mapping here. Okay. So 0 and 0th index values has to be mapped. So 1 and 1, and so second and 2 and 2 positions values has to be mapped. Okay. So for that sake, we have zip function. So in Python, 1 minute. So might be if your trainer so completed it, so no problem. So if not completed, okay. So if already completed, it revises, okay. So no problem. Just listen once again here, okay. So we have so zip function. So in Python, by using so this we can combine so the two arrays here. Actually, for some programs already they given so two arrays in combination. Okay, but for some programs we need to combine so the two arrays. Okay, so that part I'll explain here. Okay, so afterwards, so I'll explain what are the operations we are going to perform. Okay, on combining so the two arrays here. So all of you observe this. Let us take so an array here. So in this, I'm collecting so array one and next of all, so the array two values. Okay. So next after that, so let us print so that values here. Okay. Let us extract list of array. Okay. 1 minute. So fine, let us check. So everyone, so 0 and 0 position values are mapped. So first position and second position values gets mapped here. Okay. So now I want to do one thing here. So based on first position values, okay, means here in each and every position, so you're observing so one tuple, right? Okay. So this tuple is present in 0 position, this is present in first position, and this is in second position, right? Okay. So if you want to get the this one value 3, this is at 0 0 position and 2 is at 0 1 position, right? Okay, 1 is at 1 0 and 5 is at 1 1, 4 is at 2 0 and 6 is at 2 1. Okay, I hope so you understood so the positions now. Okay, so based on if we consider, so this one has some x, okay, might be lambda functions explained for you, okay, in the session. If not, okay, so please post in the chat box, okay, I'll explain, don't worry. Actually, with the help of lambda functions only, we perform so the customized sort here, okay. So afterwards, we'll start so any programming in a greedy approach, okay. So by performing so the sort, we are going to get the optimizer result. So for some programs, we need to perform ascending order, and for some programs, we need to perform descending order, and for some programs, we need to customize the sort, okay. So that's why if lambda function is not completed for any one of you, okay, or any one of the brands, so please intimate, okay, in the chat box. I'll explain, no problem. So otherwise, it becomes difficult to you to understood, okay. So next, so on consider in lambda functions, we consider some particular value or else some particular position value in the list as some x here, okay. So here, based on so this first position values, okay, or else based on some division result of so these values, we are going to perform sort, okay. You are going to observe that. So this type for performing these type of operations, we need to combine so there are two arrays here. That is what we did here, okay. Later on in the program, you are going to clearly understood so the usage of this one, okay. So fine. First, let us see the problem statement now. So have a look. You are given a schedule of n meetings, okay, with their start time, start of 5, and next of all end time, end of 5. Okay, starting times and ending times are given. So, but two different arrays are given here. Okay, remember this. Next, you have only one meeting room. Okay, remember this point carefully, everyone. Similar to this, we have the next program. Okay, so but one small change you are going to observe based on this. Okay, so here only within a one meeting room, so we should conduct so the all meetings. Okay, next to this we are going to observe number of platforms required in the railway station. Okay, so there it's not the constraint that within the some single platform we need to accommodate so the all trains. Okay, a small change is there based on that. So you are going to observe difference in the beginning itself. Okay, so just remember this. First, let us complete this one. Okay, so you need to return the maximum number of meetings you can organize here. Okay, within a meeting, single meeting room, we need to conduct so the maximum number of meetings. That is the task. Okay, and so read the note information carefully, everyone. The start time of one chosen meeting cannot be equal to the end time of other chosen meeting. Okay, this is the boundary condition. So we need to be careful with this. Okay. So how is it possible? Some particular meeting one is ending at so 10 o'clock. Some meeting two is starting so at 10 o'clock. Okay, it's not possible. But suppose meeting two is starting at 10 o'clock 1 minute means it's possible. Okay, we are going to accommodate it. So that is the thing. And one example is given here. Okay, so observe everyone. So that is n value 3 is given, number of meetings 3, and starting times of these are 136, ending times are so 487 given. Okay. So for this, actually, two meetings are only possible to conduct. Okay. I'll explain with some sample input here. Okay. So listen. So here, the greedy way of thinking, first of all, I'll explain. Okay. Based on that, what so code we have to design. Okay. So I'll explain later. Okay. So here if for suppose if we conduct so the meetings which completes quickly, okay, so that we can conduct so the maximum number of meetings, right? Okay, let us take so this example itself. Okay, we are going to clearly understood this. 1 minute. Hmm, something so 130585. So 1 minute. 2467. Yes. So these are given. These are start meeting times, right? And so next, these are end meeting times, right? So fine. So observe here. For suppose, well, consider this is meeting starting at 0th hour. Okay. So this meeting is ending at 6th hour. Okay. For suppose if we conduct so this meeting. Okay. Is there any possibility to conduct so these two meetings here? Observe everyone. This meeting is starting at so first hour, ending at second hour, and this is starting at third hour and ending at fourth hour. Okay. So in between these timings, actually, so this meeting is only happening, right? Okay. How is it possible to accommodate so these two meetings here? Okay. It's not possible, right? So uh, that's why always, so we should think about the meetings which are so completing at earliest, okay, so that we can accommodate so the maximum number of meetings here, okay. So observe here in the beginning we have so these two here. So first we are going to complete it. Afterwards we are going to check for this one. This one takes a long time, so that's why we are going to ignore it, okay. So when compared to this, we are going to conduct some two meetings here instead of this, okay. So this is the greedy way of thinking. So based on this, what I am saying here is we need to sort so the ending timings here. Okay, based on so the ending timings, we need to perform so the sort, and the start timings also has to be changed. So we should not so sort only the ending timings here. Okay, so these starting timings are in relation with the ending timings only, right? Okay, so that's why based on so the ending timings, so start timings also has to be changed. Okay. So for that sake, what we need to do, we should combine so both these two, so start and ending timings so arrays. Okay. After that, so based on so the end timings, we need to sort the start timings. Okay. In that scenario, we are going to use the lambda function. Okay. So I'll explain that. So sorting process, all this. Okay. Already here, if you carefully observe, you can understood one thing. Already, so values are given in the sorted form only. Actually, in each and every example, we won't get so input like this. But for this example, you can observe. So the ending timings are in ascending order here. Okay. So there is no problem in it. Directly, we can work with this example. I'll explain how to design it. Okay. So fine. So now I'll explain. So how we are going to design so the solution for this program. Okay. All of you listen carefully. So initially, I'm going to take so the end time as -1 because unknown it's right. So we didn't started any meeting. Okay. So initially, I'm taking some unknown value called -1. Okay. So after conducting some particular meeting, I am going to update so this end meeting time here. Okay. So fine. I hope you understood. So this one, the start and end timings, we are going to be compared. Okay. Fine. So fine. So first thing is when it is possible to conduct so any meeting. So if the current meeting start time so is crossing so the previous meeting end time, right? Okay, then only it's possible. The same condition, so we are going to check here. Okay, so whenever so start time, let us take this one as end. Okay, so that you can clearly understood. start meeting time so is crossing with the it's 1 minute. I'll update these variables so that you won't feel difficult. Let us consider so initially end meeting time as -1 and currently so we fetched these two, okay, start and end. So what we need to do here is current meeting start time. So we should compare with the so end meeting time here. Okay. So here it's initially it's 1. Okay. And initially we take an end meeting time as -1. It's possible. It's starting at first hour. Okay. So initially we take an end value as -1. Right. Okay. So actually this is from count model. Right. Okay. How many number of meetings we can conduct in the so room, right? Initially, so I'll take count as 0. Okay. Whenever it's possible to conduct any meeting, so I'm going to increment so that value here. Okay. First of all, I'm incrementing so count by 1 because it's possible to conduct the first meeting. Okay. And so next to that, afterwards, don't forget. So we need to update so end time to the current e variable here. Okay. So observe here what I am doing. So end time, so we are updating. Now it updates to the 2. Okay. So fine. Next. What is the next start and end timings? So check here, it's 3. So now the previous meeting, so the end time is 2. Yes, it's possible. Next meeting start time, so it's 3. Initially, it so taken this one, 1 minute. 1 greater than -1, it's true, that's why count incremented. So now the current start meeting time is 3 and the previous meeting end time, what is the first meeting we conducted? So this one, right? This one ended at 2. Okay, 3 greater than 2. So it's true, now it's once again possible to conduct. What we should do, we should increment count by 1 and the end time we should update with the current e variable value, that is with 4. Okay, we conducted this meeting, right? We should update. Next. So next of all, we are going to fetch so this start and end meetings time. What is the start meeting time here? Okay, it's 0, right? So 0, and what is the end meeting time here now? It's 4, right? 0 greater than 4, it's false. No, it's not possible. Okay. So next, we are going to fetch so these start and end meeting times here. So this is 5 and the previous meeting end time, okay, so it's 4. Yes, now it's possible 5 greater than so 4, it's true. If it is true means we are going to increment so count by 1 and so the end meeting time we are going to update to the current one. Okay, so that is to the 7. Next meeting start time is 8. Okay, end time is 9. Okay, and so the previous meeting ending time is 7 here. Okay, so 8 on comparing so with 7, we found that it is so 1 minute. 8 is 8 greater than 7. It's true, right? Okay. So find count. So increments to 4, and so current meeting ended at so 9. Okay. So next, final last meeting is so starting at 5th hour, should end at so 9th hour. So but so current meeting start time we should compare with the previous meeting end time. So that is 9. Okay, 5 greater than 9. Okay, so it is false. Okay, whenever it's false, it's not possible to conduct that meeting. Okay, so how many meetings totally? We ended up right. So totally how many meetings we can conduct here? Okay, so totally 4. That's it. So that is what we are going to return here. Simply, I hope you understood. We should retrieve so start timings and next of all, so the end timings. We should compare start timing with the so end variable name. We taken one separate so end variable here. This one holds the so meeting whatever we held at the so previously. Okay, this one holds previous meeting end time. Okay, current meeting end time so holds by e variable. I hope so it's clear. I clearly so given the condition also here. Okay, so fine. Whenever we found this condition is true, so what we did, we incremented so the count by 1. Okay, and afterwards we updated the end variable to the current ending time. Okay, repeatedly we did this. So I given these two expressions also here. Okay, and finally after completion of this, we need to return the count. This is how to design so the solution for this program here. So let me complete so code for this one. But before to this, you have to know one thing. So I'll explain that. Have a look. GIF function I explained, right? So let us take array values 3, 1, 2, next. Simply I'm applying so the sort, you all know this array arranges so in ascending order, right? Okay. So, but if you want in descending order, uh, so let me take so here itself array dot sort of. Actually, we have some default argument in the backend for sort that is called reverse. Initially, if we do not pass any value to this, okay, it takes that value as false. Okay. So now what I am doing here is I am changing that false value to the true. Okay. Afterwards, I am printing so the updated array here. Observe everyone. Check whether array is so sorted in descending order or not. Okay. So now you know these two, right? Okay. Well, apart from this, we have one more argument, so called key. Okay. So to this key argument, already some value called none assigned. Okay. If we do not pass any value, by default it takes none. That is called the default argument. Okay. Might be in the class. Trainers explained this default arguments. All this. Based on this, we are working it. If anything not completed, okay, remind me. So I'll explain it. Okay. Don't worry. Next. So the next thing is, so now what we need to do? We need to perform so the customize sort, right? Okay. Let us take so this one previous example 6 and next of all so the 5. Observe output everyone. Okay. So here check the what I said. So based on so the end meeting times, we need to perform so the sort on start meeting times, right? Okay, we need to combine both the start and ending times. Actually, these two arrays are given separately. Okay, we need to combine so these two arrays like this. Okay, I'm explaining step by step. Okay, so check everyone. So I'm not explaining so the continue program so at a time here. I am dividing into number of partitions. Okay. First of all, I explained so the zip method. Now I'll explain so I explained sort method. Okay. Let us see the customized sort now. Okay. So what I'm saying here is we should perform so the sort based on so the end meeting times, right? End meeting times are present if we consider this entire tuple as x. Okay. So this is present at 0 position x of 0 and this is present at x of 1 position, right? So means if we consider so this entire tuple as x, okay, we can say that x of 0 is present. So at x of 0 is 3 and next of all so the x of 1 is 2, right? Okay. I hope you clearly understood. Now what I want to do here is, okay, based on so this first position, each and every tuple is considered as x, not only this one, okay. Lambda function considers each and every tuple as an x, okay, and it is going to perform so the sort. We need to perform so based on so the first position of each and every tuple here, okay. So that is what I am going to do now. All of you observe once array dot sort. Let me check array dot sort of key argument to the key argument I am applying lambda function. Okay. Next in fractional knapsack you are going to observe a different way of sorting here based on so that problem we should find, okay, how we need to perform so the sort. Okay, that is very important here. That is the very first step you are going to observe in most of the greedy approach programs. Okay. Let us take lambda function. And next, I'm considering so each and every tuple has x here. Okay, by considering each and every tuple of x, I need to perform sort on based on x of 1, first position. See, if we perform sort based on first position, what happens? This tuple comes beginning where it will get it as it is in the same position. Next to that, you'll get this tuple, right? Because here, so this value is smaller when compared to this one. Okay. Next of all, you'll get this one. Afterwards, you are going to get this one. Okay. All of you check output at once. Okay. Whether it's interchanged or not. So I'll print both the outputs here. Check out once. Okay. I hope so it's clear. Before performing sorting, so how it is after that, so you can check. Okay, how we perform customized sort here. Three types of sortings were there, guys. Okay, one is ascending order, second one is descending order, so and the third one is customized sort. Okay, already for CSC students in my sessions, I explained this. Okay, not might be for EC, I didn't explain so the customized sort, but I explained lambda functions to one of the EC section. So for remaining sections, okay, so gone through it. So if you cannot understood, so the any lambda function, all this you can ask. Okay, GIF function, I hope say it's simple, easy. So simply we are combining some two arrays. For combining arrays, we use this GIF, and for performing so the customized sort, most of the scenarios, okay, for performing customized sort, we are going to use the lambda. Okay. Now with the combination of so all this, okay, I am going to finish that so program. Okay. So actually, this one asked in the hack with Infi also previous year. So there is not just so think that it's an interview program. Most of the interview programs, whatever you are observing, okay, you'll get it. Definitely, you are going to get on the same models also. It's not possible to discuss whatever the programs you are going to get. So 1,000 programs, all this, okay, the programs present. But the thing is, you should gone through the models. So you are going to get the programs on the same model. You should try it, okay, to try to design. So fine. Now let us complete this one. Observe what is given. Maximum meetings function is given. Start list and next of all end list. So now listen, one thing. Now I explained I given detailed explanation, right? Okay. That explanation is present here in this platform. You can check later. Don't worry about that explanation. So here, so observe two lists were given. Start list or next of all, so the end list. We need to return integer value from the so function. Okay, I'm removing comments and pass. Okay, don't remove this. Okay, function and all this. Already it's called in the backend. Okay, you are seeing the called method called functions here. Okay, don't change it and start typing. So by removing the comments. Next. So what I said, first of all, so based on so the end timings, we need to change the start timings also, right? But first of all, we need to combine so these two arrays, okay? For combining so two arrays, what I said, we need to apply GIP, right? GIP. So observe this, everyone. So I'm taking some meetings array here, okay? So I'm applying GIP of start comma end, okay? And what do you observe in the Jupyter notebook? So after printing, so the result we got the some address, hexadecimal address. Okay, how we can how I extracted so the values. So with the help of list constructor, right? By passing values to the list constructor, so we got the result, right? So that's why I'm taking within the list here. Now it's a list of tuples, nothing but next. So as good, we collected some two arrays here. Fine, there is no problem. And now the next part, important thing is in greedy approach programs, we need to sort based on ending times. If we complete at earliest, we can conduct maximum number of meetings. Okay, so that is a greedy way of thinking here. Meetings dot sort of key. Already I explained this once again. You can check here now. Okay, lambda of some it considers each and in these meetings. Okay, list array of tuples. Okay, so it considers each and every tuple as x. Okay, and it performs sort based on so the first position. Okay, in the tuple based on first position, that is on end based on end timings. Okay, it performs so the sorting on start list. Okay. Next, what I said, this is a count model program, right? So in the classroom also I explained that count, sum, max, and min model programs repeatedly. You are going to get level changes. Okay, varies approaches and all this. Okay, but the same model programs you are going to get in coding section of different companies and interviews. Okay, so remember this. Now let us do one thing. Let us take so count is equals to 0, and we need to take end time. Okay, this end time holds. Okay, so when some particular meeting is completed, okay, so that particular end time it is going to be held by this one, and the current meeting end time is going to hold by some other variable. In other variable I'm going to take, so that, okay, don't worry, end is the array list name. Okay, ending timings it contains. Okay, next, so this one holds some particular, so meet when some particular meeting ended. Okay, when the previous meeting was ended. Next, so now we need to extract, so each and every meeting start and ending time. So from these meetings, okay, array of tuples, each and every tuple we need to extract, right? Yeah, so in each and every tuple, so we have start time and next of also the end time, right? So like this. So I'll explain 1 comma 3, and so I think so 2 comma 4, right? So 0 comma 6. So start timing and next of all end. Start and end timings I'm fetching, right? Observe everyone, for start and I'm using for each loop here. So start and end timings I'm fetching from the so meetings list here. Okay, each and every tuple values I'm collecting here. Next, after collecting what I said, so one meeting start time we have to compare with the uh, so previous meeting, so the end time. Previous meeting end time, so is stored in this variable, right? So we should check if start of current meeting is crossing, so the end time, okay? The previous one, then it's possible to conduct that meeting, right? We can increment, so the count. Same thing I explained in the example. Count is equals to count plus 1, next of all. So now the end time variable we need to update with the current meeting end time, okay? So end time variable we should update with the current meeting end time. So observe this, end time is equals to, sorry, it's underscore end time is equals to E. Okay, current meeting. So with current meeting end time, so I'm updating this one. Okay, so fine. Next, likewise, it keeps on repeats. Okay, each and every meeting start time, so it's going to be compared with the updated, so the end time. If we found it's possible to conduct, okay. See, I'm not taking greater than or is equals to here. Okay, that is what explained in the given in the note. Okay, whenever it's crossing, then only it's possible to conduct meeting. Okay, otherwise it's not possible, right? Then only we should update this. Finally, after completion of the loop on returning, so the count, we are going to get, so the maximum number of meetings whatever we can conduct within the room. Okay, so this is a program, simple one. Once again, it is from easy level. Okay, directly I'm not moving to the so medium level programs here. Okay, once after completion of this, so easily you can tackle the next level programs. Okay, we have some structured approach. So I'm moving in this approach only we can reach to the destination easily. Okay, otherwise completely feel very difficult. Even though some functions like zip and so jar lambda also might be some few members feeling difficult because repeatedly you are not so observing, focusing on this. Okay, and so good, fine. So let us run and check whether it works or not. Fine. So sample test case executed. Let us submit. It's checking left side. All test cases passed here. Okay. So fine. It's working so properly. There is no problem in it. Okay. This is important when maximum meetings. Okay. You can conduct in a single room. I hope so. It's clear for everyone. If you have any doubts, you can ask. Is it possible for so chat? So I am not getting so that no one is giving reply. So if it is possible, so give reply in the chat box, okay? So that I can proceed further. It becomes easy for me. So fine, just gone through the program. So for 2 minutes, okay. Similar to this, we have another program. So that is also important. That is minimum number of platforms required in the railway station. So, but so there, that so one small change you can observe in between these programs. That is, so there it's not required that. So we should allocate all trains in the same platform. Okay. So based on the timings, okay, we need to check. So at any particular instance of time, so how many maximum, so how many number of platforms are required, okay? So that whatever the platforms required, we need to minimize here. So number of platforms required has to be minimized. So over there, let us see how to design. So for that one, so let us see the problem statement. Minimum number of platforms. So we can check it's from moderate level. Okay. So nearly 30 companies. So interviews this one asked. So let us see the problem statement. Okay. So observe the problem statement. So here also some two arrays are given. Okay. So arrival time and next of all, so the departure times. Okay. Representing arrival and departure times of all trains that reach a railway station. Okay. Your task is to find the minimum number of platforms required for the railway station so that no train needs to wait outside the railway station here. Okay. So some scenarios you are going to in real time also you are going to observe that some train is waiting outside, okay, because of not available platform, okay, but that type of scenario we should not consider here, okay, clearly mentioned in the problem statement, okay, and we need to think, okay, about I mean minimum number of platforms are required here, okay, minimum number of platforms required based on arrival and departure time. So here information is given in note regarding so these timings here. Okay, it's not required. 19:30, 24 hours from timing is given. 19:30 means 7:30 and 20 to 40 means 10:40. Likewise, you need to think. Okay, so and some information also given regarding this. One thing you need to remember here is uh, total value is given here without any colon separated form. Okay, you should so think. So how it will be if we taken so the colon. Okay, that is the thing. You need to consider. I'll explain with the help of sample input and example. Don't worry about it. Okay. So let us take so the first example, it's the best one, easily can understood. So now once again I'm explaining whatever the thing I'm going to explain here, it's clearly available in the platform. You can check the later, okay? You can clearly understood. So don't worry about so the explanation, or else you can watch so the video also again. Don't worry about this. So let us collect this input. 1 minute. So 900 something called so 940 let me take so this okay and 950 1100 1500 and so 1800 okay 1 minute so these values are given, these are arrival timings. Okay, next so let us take departure timings. Okay, 9:10, this is 12 I think so, 12 11 20 11 20 19 and 2. Okay, these are departure timings, guys. Okay, so here it's not required to so combine so the both the arrays. Okay, and to perform so the sort of departure timings based on that it's not required to change the arrival timings. Okay, so why? Because means here we need to focus on so only so the departure timings. Okay, if for suppose some particular train is staying in the so platform, okay, it's not possible to allocate so the same platform for the another train, right? Okay, so that's why so just we need to check so at any particular instance of time, so how many trains are staying at the railway station, right? Okay, so that's why so we are going to perform so the arrival timings and departure timings so the sort separately here. Okay, so it's not required to exhibit so the any relationship between so these two arrays and to perform sort one against another. Okay. So here, if you consider already this arrival timings array is in sorted form, you can check. Okay. So, but departure timings it's not in sorted form. Let us sort it. Okay. First of all, let me write so once again 950. Let us sort departure timings. It might be you may get one doubt now, sir. Now, departure and arrival timings of trains may changes, right? Okay, there is no problem in it. Here, the thing is we are not focusing on so the same train. Okay, arrival time and so the departure time here. We are focusing on some and any particular instance of time, how many trains are staying here, okay? So this one separately we are sorting here. So first of all, 9, 10 only. Next of all, so 11, 20. Next, so 11:30. Next, so 12 o'clock. Next of all, 19 means 7 o'clock. So 20 means 8 o'clock. I hope so you understood so the meanings of this. Okay, 15 means 3 o'clock. Okay, 9:40 means 9 colon 40, 9:50. I hope so you understood all this. So now the thing is, uh, when it's required to allocate so the any platform, so whenever, so let us take so this one, some part first position, so index arrival and departure time. Okay, it is arriving at 9:40, and that same train is not departing at 11:20. But if you take okay this first position departure time, it's leaving at 11:20. Is it possible to allocate that same platform okay to this train? No. So means here once again we need to compare one train arrival time with the so previous train departure time. Okay, I hope so you understood here. One train arrival time we need to compare with the so another time departure time. If it is so more than that, okay, yes. So it's not required to allocate another platform. Okay, but it is still behind of so the previous train so the departure time. Now yes, it's required to allocate one more platform. One minute. Okay, fine. Next, let us take so this one. 11 o'clock. So next one is arriving at 11 o'clock. So this train is leaving at 11:20 and this train is leaving at 11:30. No, it's not possible to allocate to the same platform. Okay. So again, one more platform so is required for this. So simple the thing is, so one train arrival time, so we need to compare with the so another time departure time. So the here the greedy way of thinking here is okay. So if we sort departure timings, okay, in the ascending order, with that is once again with the lowest values, okay. Again, with the minimum number of platforms, we can end up, okay. So forming the railway station here, okay. So that is what you are going to observe in this program, okay. So I'll explain initially with this example, okay. Later on, clearly you can understood. So in the platform also, okay. So I'll start from the beginning now. So all of you check it once, okay. So I variable I'll take for so arrival time and so J variable I'll take for departure timings array. Okay. And so this is so here how many platforms are required? Okay. We need to count it, right? This is also once again from count. Okay. But count and max model combination here. Okay. So count, so variable I am taking as P. P means platform, okay. And so initially I'll take a platform count, so the zero. We didn't allocate it, so the any platforms here. Maximum how many number of platforms should be allocated? We are going to store in this variable, okay. So I understood. So for some branches might be. So I think so. Max and min model programs also count model all these completed from the arrays. Okay. So you are going to observe in combination. That is the next level. Might be some combination models may not be completed in the CRT. Don't worry. So I'll explain from the scratch till try to understood. Okay. So what I am saying here is okay. And once again, the same thing you need to remember here. That is, I think so. Forgot to explain one more thing. Yeah, this one. Read this one. The departure time so will always be greater than the arrival time, guys. Okay. So then only every time we depart on the same time, and so this information is given. And so if some train is entering at some 10 o'clock, okay, and some train is leaving, so by yeah, fine, fine. So leaving at some train is leaving at 10 o'clock and some other train is entering at 10 o'clock, it's not possible to accommodate the same platform. We need to allocate the another one. Okay. So remember this point, and based on that, I'm going to design the logic here. Okay. So first thing, so we are at 0, 0 position, right? Okay. So initially we need to check arrival train of, sorry, arrival time of I position value. We should compare whether if it is less than or else equivalent of departure time, okay, of I. So then what we need to do, we need to allocate so the one platform, right? Okay. Yes. Now if you check 9 o'clock is less than of so 9:10, right? What we need to do, we should allocate one platform. So I'm incrementing so by one. Okay. Next, so at any particular instance of time, how many platforms required? Okay, we are going to store in this max variable. So now this max variable value I am updating with the so current platform count. Okay, so fine. After that, so only I variable value I am updating here. So not both so I and j. Okay, I variable value I updated here. Initially we taken to the 0 position. Got it? Okay, next. So next, what is the next value here? 940 and so 920, right? So on comparing, so the 940 with the so 910, it's not less than, right? Okay. So now what we need to do? So we should decrement so the platform count here. Okay. Decrement platform count here, and we should update so j variable to that. Yes. Once again, we'll go for checking. So I and j position values. Once again, it's smaller, right? Once again, we are going to increment count by one. But so this time max is not updating here. It remains the same. And next. So what I said, on allocating some platform, we need to update I variable only, right? Okay, not j. Now, if you check here, you can clearly understood so this program. 950, some other train is entering at 950, but so one train is staying at, so in platform number one, train is so stays up to 11 o'clock, 11 and 20. Okay, it's not possible to allocate so the same platform, right? Now what we need to do, platform count we should increment so by one, and so max variable also I'm incrementing by one. So here in platform variable, I am going to update. So by incrementing and decrementing. Okay. If it is any a train is leaving, I am decrementing so the platform by one. If any train is arriving, okay. But at any particular instance of time, how many trains are there at so railway station, we came to know with the help of this max variable. I hope you understood. Okay, fine. This is the condition for incrementing so the platform. Okay. Next I. If this condition fails, j variable we are going to decrement, and platform j variable we are going to increment, and platform count we are going to decrement. Again, this is true. 11 o'clock. Now arrival time of I is 11 o'clock. Okay. Departure time of some j position value. Okay. So it's 11:20. Now, yes, once again, so another platform is required. Okay. And the max variable also I'm updating with that. Okay. Next, I variable we are updating, but so on comparing with these two, 15, that is 3 o'clock and 11:20, this train is leaving, right? Okay. What we should do, we should increase position and we should decrement platform count by one now. Okay. Again, on checking, so the arrival time of I position value with the departure time of j position value. Again, yes, this train also going to leave. J variable we are going to increment, and platform count decrement. Okay. Again, so it's 12, right? So yes, this train enters at 3 o'clock. Another train is going to leave from the platform. J variable we should increment. So what happens now? Again, so platform count finally reaches to 0. Okay. But now I'm checking I and j position values. It's less than of j position, right? Platform count we are going to increment. This train arrives at 3 o'clock and so stays up to 7 o'clock. Okay. Now I variable I updated to the so next position here. Okay. So now on comparing, so 18 with so 19, yes, we can found that so one more platform is required here. So, but I variable reaches to the ending. Okay. So means it's not required to traverse further ending. So here you can clearly understood that whenever I reaches, definitely I only reaches to the ending. Okay, J remains at the previous positions only. Okay, whenever I variable reaches to the ending position, so we are going to stop this, and finally we are going to return so the max variable value. Here at max, three platforms are required. Okay, at any particular instance of time, some three so platforms are required. Okay, that is what. So you are going to observe. You observed in this example also. Okay, have a look. So for this first sample input, observe the sample output is one. Okay, sorry, three. For this second example, sample input, the sample output. So for the second sample input is sample output is two. Okay, this one clearly you can understood once again with this explanation. Okay, so fine. Now I'll go with the explanation. Wait for 1 minute. Let us say the coding screen first of all. So what is given? Okay. So here if you observe carefully, so already they taken number of test case values. So based on, I think so in worker tech platforms, so trainers also explained, okay, how to work with the test cases, okay. Based on that, so arrival and departure timings are taken and so passed to the, so this one, minimum number of platforms. Okay, here input is taken for arrival and departure timings. Okay, next of all, so those arrival, departure timings and the number of platforms. Okay, uh, n number of so length of arrival time and departure time passed to here. Okay, so just we need to work in this function. That's it. Okay, we need to remove the comments and pass, and we should start typing. So here. Okay, so fine. So let us start. What is the first step? Okay, the very first step you are going to observe in most of the greedy approach programs is so sort, right? Okay, let us sort. So arrival and departure timing. So the separately here, okay, arrival time dot sort and next of all, so the departure time dot sort. Okay, it's not required to so combine. Okay, see, based on the problem, so we should go for so these changes. Actually, there n number of meetings we should conduct within the one room. Okay, there it is must and should to exhibit the relationship between so the start timing and end timings. Okay, we need to perform so the sort on based on end timings. So start timings has to be changed. But here, so based on so some arrival timing, if it is exceeds, okay, if it is lies within the departure time of so the other train, okay, it's not possible to allocate the same platform. That's why we need to go for extension. Okay, so we are not waiting. Okay, so for allocating, so for we are not allocating so the same train in the same platform here. Okay, we are not waiting here. There is a difference based on that. So we perform so the sort separately. I hope so. It's clear for everyone. So I variable we should take for arrival time and J variable for departure time. So alright, next. So platform, so at any particular instance of time, okay, how many number of platforms required? So we are going to store in max, okay, and so on arrival, if it is positive, if any train is leaving, okay, we are going to decrement it. If it is any train is arriving, okay, we are going to increment it. So for that sake, I taken so the platform here. Initially, I'm taking so the all values to the zeros, okay, and next what I said. So I variable on reaching to the so size of an array. We need to stop it, right? Okay. Definitely I variable only so is going to exceed the size of array. So not j. So this is what you observed in the example also. Even So if we are at same, we started I and j at the same indexes, okay. Finally, if I and j also moves to the same index, okay, so that is to the last index. Afterwards, I only is going to be updated to the next index. That's why we need to take so the condition as I less than n here, okay. And what I said, 1 minute. So one train arrival time. So we need to compare so with the another time, so the departure time, right? Okay, for departure, so array we taken so the j variable. Okay, for arrival time, so we take an I variable. So if we found even so the both are matching. So we need to go for allocating so the platform, right? Okay. So means I'm incrementing so the platform count by one here. Platform is equals to platform plus one. Okay, so wait. And next, so after incrementing, what I said, at any particular instance of time, how many minimum number of platforms required? Okay, so we need to store in this variable, right? Okay, so I'm calculating whether so the current platform count, okay, and the maximum variable, so are max or not. Which one, whatever it's max, okay, it's going to be stored in the max variable, right? So observe this, everyone. Max is equals to max of so platform count and next of all, so the max variable. So let us take like this. Max variable value, simply we are comparing with the platform, but directly I'm using so the max function here, okay? So might be in your classes, so they explain like this. So platform greater than max, if it is true, max is equals to the platform. Both are same, okay? Instead of so these two lines, we are using this line, okay? Hope you understood. Don't worry about this. So fine. What is it? If found any arrival time is less than, okay. Yes, now we should go for check. So whether it's possible to whether it's required to allocate another platform so for the next train or not. Okay, that's why we need to increment so the I variable value by one. So if not, so then we should reduce the platform count by one. Okay, that is if any train is leaving, so we need to reduce platform count by one, and we should increment so the j count by one. Okay, j index by one in that scenario. So observe this else. So platform and so decrementing so by one and j variable value incrementing so by one. I is equals to I plus one. Next of all, so the j is equals to j plus one. Okay. For understanding so clearly, so I'm taking so the full form here, detailed expression. So like this, so it keeps on updates either I variable or else j variable. So might be continuously I variable updates and it keeps on checks. Okay. So if still arrival time of any particular train is less than of departure time of say any other so particular train, so we keep on increments to the platform count. Okay. So by keep on incrementing, so we update so the max variable. Okay. So at that particular time, how many minimum so platforms are required like that. Okay. So if not, so if it is greater than, if any arrival time is greater than, some train is leaving, right? Okay, from the platform, so we are decrementing it. Okay, and we need to make comparison with the another train departure time. That's why we are incrementing so the j variable by one here. Okay, so like this by keep on updating. So this finally we are going to get the minimum number of platforms required in max variable. So we need to return that. Okay. So that's it. Let us check. So let us run. And so base case executed. Let us submit. So observe everyone. Yeah, all test cases so passed here. Okay. This is from medium level, guys. Okay. Uh, from medium, moderate level. Okay. But so if you take this one is similar to this n number of meetings. Okay. Only some few changes you can observe here. That's it. So that's why I said, so once after observing, so from the models, so you should try to practice more number of models from your end also, okay? Then only it's possible to achieve these type of, then only it's possible to crack these type of rice, okay? So just by listening to my classes, I won't say that you are going to get it. Okay, it's definitely on so difficult level. You all know this. Okay, don't give up. So if I complete some four programs from my end, okay, if you complete some four programs from your end, okay, definitely might be any chances are there, right? Okay, to get the program from those questions, okay, or else you may get the same programs also from those programs, whatever you observed. The chance are there to get the question. That's why don't give up, okay? So keep on trying. And so I think so we have some 20 minutes of time, okay? Um, one program is remaining. So from greedy approach, and that too, that is also very important one, okay? So by explaining, so that one I'll stop. So this session, today's session here, okay, and very important one. So for interviews, when compared to all this, okay, so that is knapsack might be in your academics also. Actually, some colleges actually advisory as a subject is there in academics in that. So they are studying. If present in your academics, it's fine, no problem. Or else I'll explain from the scratch. Don't worry, okay. So last one, guys. Okay. After completion of this, I'll stop it. Okay. This is from easy level only. Okay. This one also asked in nearly some eight companies interviews. But when compared to this, observe this knapsack. How many times it's repeatedly asking? So 2 plus 39, 41 companies interviews. This is from moderate level. You are going to observe from dynamic programming. Okay. So good. Fine. First of all, so I'll explain. So the program, okay. Later on, let us see the problem statement. So there, first let me complete problem statement. Okay, you have been given weights and values of n items here. Okay, some items weights and next of all, so the cost so is given here. You are also given a knapsack of size W. Okay, uh, some knapsack means in Telugu we call it as sanchi. Okay, might be you know this. Okay, actually, this problem is belongs to some thief. Okay, likewise, you are going to observe in a 01 knapsack. Okay, so now it's commonly given some knapsack of size W. It's having some capacity, right? Okay, that utmost capacity is given here. Okay, that is represented as uppercase W in the problem statement. So what is our task is to put the items in the knapsack such that the total value of items in the knapsack is maximum. Means we need to get the maximum profit. So by picking so the values by picking the items here. Okay, how we can pick so the items for getting so the maximum profit you are going to observe here and observe that read note information everyone. So you are allowed to break the items here. Okay, so actually, I said right, we have one more program called 01 Knapsack. In that, actually, it's not required to allow to break the items. Okay, either we need to consider pick some particular item, or else we should not pick the item. Okay, so by not picking, we should go for so checking whether it's possible to pick another item or not. Likewise, you are going to observe in 01 Knapsack. Okay, but here it's allowed to break the item. So I'll explain with some best example. Okay, so all of you observe at once. So let us take some weights called 10, 20, 30. Okay, and let us take some values called 60, 100, and so 120. Okay. So now the thing is, okay, let us take some knapsack capacity, so called 50 kgs. Okay. Knapsack capacity, let us take some 50 kgs, guys. Okay. So, first of all, greedy, right? Okay, so greedy way of thinking is on picking so the maximum value item, so we are going to get the maximum profit, right? Okay, so first of all, so if we go for so picking so this item, we are going to get some 120 rupees profit. Okay, so here this is from some model, guys. Okay, initially you know how to start some model programs. Okay, initially we should take sum to zero. Okay, next. So now the thing is, it is possible to pick some particular item or not. We should check. Okay, what is the knapsack capacity? 50, right? Okay, what is the current item weight? Okay, it's 30, right? So we should compare. So weight of some particular so position value if it is possible, if it is less than or else equivalent of knapsack capacity, right? If particular position item, so I'm taking index as I here. Okay, if it is possible to pick, how we can check whether it's possible to pick or not means if that particular position item weight is less than or equivalent of knapsack capacity, then it's possible, right? Okay, what we need to do, so that particular value we need to add, right? So to the sum we need to add so that particular so value. In short, I am typing so I'm writing program also here. Okay, so means how much you can consider. So here sum becomes 120, right? Okay, and after picking some any item we need to reduce the knapsack capacity here, right? Okay. So these three lines are major for this program here. Okay, observe here. Knapsack capacity, I am reducing here. Okay, so with the current position weight. Okay, so that what happens? It reduces to 20, right? Only 20 kgs remain. After picking some 30 kgs product, okay, only 20 kgs item is removed. Next, what is the next? So product having so the maximum value. Okay, this one, right? Okay, on picking so this one you are going to get the maximum profit, right? So but on picking so this one, how much kgs it is? Okay, the weight of that product is 20 kgs. Okay, so how much knapsack capacity is remaining here? 20. Yes, it's possible. Once again this condition becomes true. Okay, so what we can do now, we can collect this item here. So now this one, sum increments to 220. Earlier, so some result is 120 and the current value is 100. And adding, we are going to get 220. And now we should reduce this particular item weight from the knapsack capacity, right? Finally, it becomes so the zero. Is it possible to pick the next item? No, right? Okay. So finally, if you check, so we are going to get result 220. But is it max means, is it the maximum amount we are going to get by so picking the items like this means no, it's not correct. Okay. So I said right, it is based on some thief. Okay. So actually, thief enters into some stores. Okay, and he's having knowledge on some weights and values, all this. Okay, based on this he's go if he go for picking so like this, okay, he'll get so the result like this, but we have some knowledge on greedy approach. Okay, so what is the greedy way of thinking here? So I'll explain whether so this 120 value item is the maximum one or not. Okay, let us check in detail how we need to consider. I'll explain all this. Okay, and so here we need to collect so the breakable items only. Okay, means in 01 knapsack, so we have some products like a fridge, microwave oven, so washing machine like that. Okay, but here, so you can consider like some fruits, vegetables like this also. Okay, so they can we can take from some fraction also, right? So the type of items we are going to consider here. Okay, so now I'll explain. Remember this 220 value, whether it's max or not, we are going to observe now. Okay. So fine. Now if you take so per kg cost. So this one gives you 6 rupees and this one gives you 5 rupees. So means I hope you understood. 60 divided by 10 you'll get so 6, okay. 100 divided by 20 you'll get so 5 and 120 divided by 30 you are going to get so 4, okay. Actually this one these values you are getting in so descending order only, but you won't get like this, okay, for each and every example. So remember this point, okay. And now the thing is so here if you check, so this one so gives you the maximum profit because per kg cost is 6 rupees here for this one. Okay. So now let us start. So by checking like this, okay, in this direction. So means per kg cost we got right. So if we traverse in this direction, if we sort so these values based on per kg cost, we are going to get in this order. Already we got in the same order only. Now I'm traversing like this. What is the result we are going to get? What is the first item? So it's 10 kgs, right? How much profit we are going to get? 60. Okay. So find 60 we are going to get, and knapsack capacity is going to be reduced by so 10 kgs. It is 40 now. Okay. Next. And moving to the next one, check whether it's possible to pick this one or not. Okay, it's true. It's possible to pick this because current knapsack capacity so is 40 and the current item weight is 20. 20 less than or is equals to 40. It's true. Now let us go for picking. So this one. So how much it becomes now? 160, right? Next. So after collecting this item, we need to reduce the knapsack capacity, right? So it becomes 20 now. Okay. Next. Let us move on to the next position. Now, is it possible to pick this total item? So having 30 kgs? No, because knapsack capacity is 20 kgs, right? So only 20 kgs is remaining. So among these 30 kgs, we should go for collecting so that 20 kgs here. Okay. How we can so make that one means on dividing so on getting some per kg cost, okay. So if you multiply with the leftover knapsack capacity, okay. So means value by weight. So result you are going to get right. That one you need to multiply with the leftover knapsack capacity. On multiplying with leftover knapsack capacity, so 4 multiplication of 20, we are going to get result 80 here. What is the previous result? 160. What is the current result? So on collecting some fraction part of this last item, 80, right? 80 plus 160, it becomes the 240 here. When compared to the previous one, previously we got 220 profit, right? Okay. Compared to the previous one, so current, so we got more profit. Okay. So this is the way of greedy thinking here. Okay. In this program, so on performing, so sort based on per kg cost. Okay. We are going to get the so maximized result. Okay. So that's what I said in the beginning. Okay, for different programs, we need to perform so the different sorting. So initially, you are observing so the all approaches here. Okay, in 3 programs, you observed 3 different ways of so performing so sort. Okay, like so by remembering so all this logic. Okay, you should go for so thinking different in all these ways. So for applying so the logic for the new program. Okay, whether it's possible to apply some particular thing or not. Likewise, you should go for checking all these logics, whatever you studied, you learned here. Okay, so fine. So this is the way how we are going to perform. So how we are going to design so the solution here. So here it's not required to combine so the weights array and values array. Based on that, it's not performed to sort based on per kg cost because already both weights and values list is given in combination. So I'll give explain in detail with the help of comments. Okay. So all of you listen carefully. Uh, Let us check. See what is given here. Okay, check everyone. So items is given here. Items means it's clearly given. Actually, I think so. It's fine. Read this. I'll just delete this one so that you can clearly understood. See, items contains weight value pairs. Okay, for suppose let us consider our example that is 10, 60, 20, 100, and so 30, 120. Okay, so already it is given in this format. Okay, it's not required to apply any zip like that. Okay, in just like in n matings program, already array of tuples is given. Okay, weight value pairs. So what we need to do here is, okay, by considering some each and every tuple as x, okay, we need to perform sort based on dividing x of 1 with x of 0. With that x of 1 divisible result of x of 0, we need to perform so the customized sort here, okay. So let me finish that. I told you already the very first step you are going to observe this. This is the greedy way of thinking here per kg cost, okay. So key is equals to lambda by considering every tuple as x. Okay, we need to divide x1 with the x of 0, right? With that result, we need to perform so the sort. Okay, x colon x of 1 divided by x of 0. With this result, we need to perform so the sort. Okay. So I hope so you understood. So this one now what I said, this is from some model, right? Initially we should take some model programs. We need to start with 0. So many times we explained in the class. The next, so we need to run. So for all the items here, I am taking so the for loop for I in range of so n. Next, so what I said. Here this is items array, right? Okay, this is items array, right? Next of all, so items of some I0. Remember I0 for means I0 means 0, 0, 1, 0. So in I variable, I'm going to get different indexes. Okay, you observed in the for loop here. So 2, 0. These positions are nothing but weights. Okay, I1, I2, I3 means 0, 1, 1, 1, 2, 1. These positions, so values belongs to the so values. Got it? So means what I said initially, we should compare so weight of each and every item so with the knapsack capacity. So weights item of I0 represents so weights, right? Okay. Next, so items of I1 represent so values. Remember this. So now we should compare so I0 position. So that is weights with the so knapsack capacity, right? So let us check now. That is items of I0. We need to compare whether it's less than or else equivalent of knapsack capacitor. As if it is less than, as we can collect that item into the knapsack, right? Okay. So means we should add that particular so item value, okay, to the sum. So sum expression is sum is equals to sum plus. So items of what I said, values are present in so 1 positions, right? 0, 1, 1, 1, 2, 1 positions. These values we are getting in indexes and 1 is common here, okay? Items of I1. And next what I said, so particular item, so value weight is uh, knapsack capacity we need to reduce, right? Okay, with that particular item weight. So that is what you can observe here. Knapsack weight. I'm reducing here with the help of items of I0. Okay. But suppose if it is not possible to pick any item, you observe the same thing for the last tuple here. Okay. What I said, we should collect part of it. Okay, that part I'm explaining. So the else block here. Okay, observe here what I said to the sum. We need to take only the part. First of all, we should take per kg cost. To that per kg cost, the leftover knapsack capacity has to be multiplied, right? So observe this, everyone. Items of I1 divided by items of I0 on multiplying with the leftover knapsack capacity, you can finish it. Although if some indexes values are present, okay, it's not required to work with, you can stop there itself. Already when control moves to the else block, so whenever we are correcting from the fraction part only, right? So we are collecting, so the with this total knapsack capacity is going to become so zero, okay? That's why it's not required to work further. That's why I use the break here, okay? And so finally, after completion of the loop, whatever the profit we got here into the sum variable, we need to return, okay, from the function. So this one collects the main and prints the result, okay. Under the output screen, let us check. So by run and submit, okay. So we got one error, item, sorry, here where we used items, very good. Here, it's sort, items dot sort. Let us take double forward slash here. Oh, 1 minute. So we forgot to sort in descending order. Okay. See, just we are performing, so the customer is sort here. That's it. Actually, we need to get so the maximum profit, right? Maximum profit when you'll get, okay, with the maximum value item only, right? But that maximum value item we should get so with the per kg cost, right? So that's why we need to apply so the reverse true here. This is from descending order. So now let us check here at once again. Yes, now base case is executed. Let us submit now.